the very first thing that falls into that bucket is simply getting access to power. And this is the first number one most difficult thing in the industry right now. The entire US is power constrained. The entire world is power constrained. And I believe we'll actually run out of power long before we'll run out of AI demand.
Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI in the Future of Work. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. Our community is growing. We recently eclipsed 1 million listeners. And thanks to all of you. We're going to keep bringing you more great conversations every week. We also started a newsletter, as hopefully you know. We've been doing it now for, I think, over a year. If you're not already subscribed, why aren't you? Click the link in the show notes. Join us over there. We share some tips and some fun facts that don't always make it into the main episode. If you like what we do, it is your obligation to share AI in the Future of Work with a friend. We're all in this together. When you share podcasts like this one, you tell others that you care about using AI to make humans better. And of course, if someone you know shared this with you, tell them thanks and pay it forward. If you leave a comment, I may share it in an upcoming episode, like this one from Ralph in Phoenix, who teaches college physics. Ralph's favorite episode is number 271 with Dr. John Boudreau, one of my favorites, a future of work pioneer and former professor at Cornell, who shared with us his insights on the new definition of work. Of course, we will share a link to that one in the show notes. We learn from AI thought leaders weekly on the show. The added bonus, you get one AI fun fact. Here it is for today. Alan Baratz writes in Fast Company that quantum computing is a path to energy-efficient AI. One of the biggest barriers to widespread AI deployment is access to power. The World Economic Forum projects a doubling of energy use by data centers from 2024 to 2027, driven by the energy-intensive nature of AI workloads. Quantum computers could be the key to reducing AI's rising energy consumption, offering a more efficient, scalable solution. Unlike traditional computers that evaluate one possibility at a time, quantum computers are designed to explore complex problem landscapes more efficiently, making them well-suited for tackling challenges that can be difficult, time-consuming, or costly for classical systems. This enables them to potentially provide solutions faster, at higher quality, and with greater efficiency. We will, of course, link to the full article, which is an interesting read. My commentary, quantum computing is a technology we must explore now, and also a reminder why investing in basic science research is so critical, even when commercial applications may be as much as a decade or more away. It's likely that achieving AI breakthroughs in things like drug discovery, increasing crop yields, curing cancer, and reducing the impact of climate change may all be dependent on whatever comes after large language models, and quantum computing could accelerate those breakthroughs. Much like, say, nuclear energy, quantum computing may seem like it's perpetually a decade away from broad use, but the experimentation required to understand its potential is likely to lead to new questions and new technologies that are impossible to imagine otherwise. Breakthroughs that enable human evolution from fire to the wheel to semiconductor all resulted from long periods of innovation drought, followed by bursts of rapid progress. Basic science is not a distraction. It's not a waste of public funds. It's the only path to ensuring humanity continues to evolve and benefit from innovative new technologies. Now, shifting to this week's conversation. Darrick Horton, TensorWave CEO and co-founder, had a bold vision in 2023 to democratize access to cutting-edge AI compute, and he made the controversial decision to build on AMD chips instead of Nvidia. Since then, he and the team have raised nearly $150 million from Magnetar, AMD Ventures, Prosperity 7, and others, and deployed a dedicated training cluster of around 8,000 AMD Instinct MI325X GPUs. They're already at a revenue run rate of over $100 million and plan to grow to more than 100 people by the end of 2025. Darrick's a serial entrepreneur who is no stranger to launching successful infrastructure companies. Prior to TensorWave, he co-founded VMAccel, sold Let's Rolo to LifeKey, and co-founded crypto mining company VaultMiner. He received degrees in physics and mechanical engineering from Andrews University in Berrien Spring, Michigan. Go Cardinals. And without further ado, Darrick, it's my pleasure to welcome you to AI in the Future of Work. Let's get started by having you share a bit more about your background and what led up to TensorWave.
Yeah, thank you for having me. It's great to be here. Just a quick clarification on that. I did not receive those degrees. I dropped out early to pursue business, and I haven't looked back since. But I did study mechanical engineering and physics, particularly plasma physics. It's actually where I started my career. I was a mechanical engineer and plasma physicist at Lockheed Martin for a brief time on a team called Skunk, where I worked on nuclear fusion energy. And that has really been, it kickstarted the love of infrastructure for me. I've always been interested in energy and infrastructure and computer science. And as this AI boom happened, really wanted to get involved, right? So it was really clear to us at the time, 3 years ago now, 2.5 years ago now, there was a massive need for AI compute at that time, right? That continues today. And it, at the time and even today, has been underserved by existing solutions, right? That really kickstarted us to start this company and focus on providing a viable alternative to the status quo. I can give some more background on kind of how the market was evolving at that time. But that's fundamentally how we got here and why we started the company.
Now, when you started the company, you made what was at the time an unorthodox decision to bet on AMD instead of, say, Nvidia. And I think since then that decision's been validated. We're recording this shortly after the big announcement about the circular investment between OpenAI and AMD. Lisa Su has certainly become a very high-profile figure, the CEO of AMD. And AMD is clearly now seen as a viable alternative to Nvidia. Talk us through the genesis of that decision.
Yeah, that's a great question. So if you rewind, go back to 2020, 2021, 2022, ChatGPT came out, sudden massive demand. And at the time, there was only one option on the market. Nvidia GPUs were the only things that were AI ready at that time. And so it was pretty straightforward to move forward. As an AI company, you had one choice and you just needed to scale that out. But very quickly, AI capacity started getting very difficult to get access to. And that was due to a number of factors, primarily because NVIDIA was the only provider. Anytime NVIDIA had supply chain constraints, everyone felt it, right? If you couldn't get GPUs direct from NVIDIA, prices everywhere else went sky high. Anyone that did have GPUs was in advantage. And NVIDIA couldn't keep up. And even when they could keep up, right, they had basically a monopoly. So pricing was not good, access was not good. And the people that paid the price for that were the innovators, and the AI innovators that couldn't get access to the technology they needed to do what they needed to do. And we saw that and saw this just massive demand for AI compute. And when we looked into it, we found that people didn't really care if it had an NVIDIA logo on it or not. They care about some things. That's not one of them, right? Of course, they care about cost, and they care about accessibility, time to market. They care about all those things. But the thing they care about the most is actually ease of use, simplicity, seamlessness. And that was something that at the time NVIDIA was doing very well in, because they had this long history of developing CUDA for AI and other HPC workloads, but it was very well aligned for AI, whereas no one else in the industry had made that investment. But when we understood what the customers were actually looking for, like they don't actually care if it's Nvidia, as long as they can do what they need to do in a simple way. Once we understood that, we started asking ourselves the question: is there something else that we can bring to market that is completely independent from Nvidia and their supply chain and their business practices that checks that box? That is, not only cost effective and scalable, but also that is easy to use and seamless to integrate into existing AI workflows. And the answer at the time was no. There was no such thing. But we saw the writing on the wall, and we already had some strategic engagements with AMD at the time, and had studied AMD's upcoming platform, right? The first real production scale AI data center GPU from AMD. It was the MI300X, and that started shipping late 2023. And so that was upcoming at the time, and we saw that and said, "Hey, well, AMD is taking this very seriously, and out of all the companies, AMD is probably the best positioned to challenge Nvidia." And the reason is, in order to reasonably be able to challenge Nvidia, not only do you have to have good hardware, but you also have to have production capacity, right? You can have the best chip in the world, but if you can only, create a tiny fraction of what's necessary, you're not going to achieve wide adoption. So having production capacity, which AMD has a ton of because of their huge CPU businesses and FPGA business, NIC businesses, they have a lot of production capacity. And AMD was also already doing the work to invest many billions of dollars into their software ecosystem, which admittedly at the time was not as advanced as NVIDIA's, but the rate of progress that we saw was impressive. And we could see that it was going to catch up and eventually eclipse NVIDIA's own software stack. And so we looked at all those factors and said, hey, look, the only one that can really challenge NVIDIA here is AMD. Looking at other providers, looking at Intel, for example, Intel was also kind of gearing up their AI strategy, but we could already also see the writing on the wall for what would unfold with Intel over the next couple of years, and now Intel is not in the game at all. And AMD having successfully initiated and executed on a strategy to take the majority of market share from Intel on the CPU side, that data point is, it's all the proof you need that they have the capability to do this with NVIDIA as well. So we looked at all those things together. And then also we really resonated with AMD in terms of just fundamental ethos. They are very committed to open source technologies and making things more accessible instead of creating this walled garden that NVIDIA has been doing. And we think that is beneficial for the community and the ecosystem as a whole over the long run. Over the long run, open wins, period, right? And that's played out many times in this industry. And we see it playing out here as well.
Now, this is going to be obvious to you, but it's perhaps not to me and probably not to our listeners. This rise of, call it kind of the neo cloud, of which TensorWave is one, maybe a Nebius, CoreWeave, others in that cohort, are having to defend why there's a need for neo cloud when many would think that the incumbent for AI workloads might be the, say, traditional clouds, your AWS and your Azure, GCP, et cetera. What is it about AI workloads that requires this kind of new approach to data centers?
That's a great question. There's a few elements that make it very difficult for legacy providers and give neoclouds an edge. One of the key elements is just speed. The rates that these clusters need to be deployed at is so much faster than what a traditional hyperscaler is used to and can accommodate. The GPU in question becomes irrelevant before hyperscalers even finish their validation cycle. generally the hyperscalers are taking a year or more to validate a new platform, to validate new GPUs, to deploy it after that. They're never adopting things on day one historically, right? So that's part of it. Another part is just how different operating these clusters, how different of an experience that is from operating traditional cloud infrastructure. Um, this is more akin to HPC than it is cloud, right? We're not operating a bunch of individual compute servers. We're operating a cohesive cluster. And that comes with many non-trivial challenges, right? You don't see hyperscalers being the ones operating all of the national labs, right? And there's a reason for that. It's a very different skill set. So it is non-trivial to operate a cluster at scale, and the requirements and the metrics that we're optimizing for, speed being one of them, but also just extreme reliability, making sure that the AI workloads get through unscathed, even even in an environment where GPUs are failing left and right, network links are failing. It's a well-known fact in this industry that the GPUs, especially off the truck, fail with double-digit percentage rates, right? It can be 20% or more. DOA and short-term failures, and that's completely unheard of in traditional cloud. And it's just because the industry as a whole is just pushing the boundaries so much every single year, constantly on the bleeding edge. Now we have newer technologies that are being unfolded, like Ultra Ethernet, UA Link, that are again bleeding edge, pushing boundaries. Every single time one of these new technologies gets released or something innovative is pushed out, neoclouds have the ability to respond to that much faster and get it into production faster, be a lot more agile and feeling the needs of AI customers. Whereas legacy hyperscalers they have a lot more momentum in a certain direction, traditional cloud, and it's much more difficult for them to be nimble, pivot, and deploy this type of infrastructure quickly and successfully.
So based on that answer, I think I know the answer to the next one, but I'm going to ask anyway, because you're talking to a lot of entrepreneurs. And I mentioned in the intro, you've raised about $150 million from just a murderer's row of investors. I mentioned Magnetar, AMD Ventures, Prosperity 7, et cetera. When you were pitching those investors, very credible investors, I suspect a lot of what you had to do is talk about your moat, what's defensible about your business. What was your perspective on what makes it hard to replicate what you and the team are building?
Yeah, well, it's hard to overstate how challenging and non-trivial it is to operate these clusters at scale. Part of our core strategy here is that we have intense focus on doing what we do and being the best in the world at it. This is why, in large part, we have an AMD-only strategy, right? Many investors and customers and people in the industry have asked us the question, why don't you deploy both, right? There's so much demand for Nvidia. Why aren't you capitalizing on that while fleshing out, AMD deployments? And the answer is, if we did that, we would be mediocre at both. And there are other clouds doing that. We believe that the way to win and be successful in this industry is to be the world's best at the thing that we're choosing to do. And the thing that we're choosing to do and focus on is being the best provider of AMD infrastructure. And that focus is clear and key. Having focus on that singular vision is what enables us to outperform and is what makes it very difficult for others to follow us and catch up. Because if you're split, if you're working on multiple things, if you don't have that clear vision and clear focus, you're never going to be able to match what we can do, and definitely not in the same time frame, right? So having that clear focus is so crucial.
I saw you give an overview of TensorWave at an AMD event, and you shared a picture of a cluster of GPUs, perhaps even your first one. And You talked a little bit about the complexities of what you constructed. If you just read the headlines, I think the assumption is that the biggest constraint to achieving like what you've achieved at TensorWave is limited access to the GPUs. But what I heard you say on stage was there are a bunch of challenges, and they go way beyond just getting access to the GPUs. It's everything from obviously networking them together and getting the power and cooling them and just a lot of other things en route to delivering the service that your customers are purchasing. In your estimation, what has been either the biggest surprise or specifically the most challenging part about bringing that service to market?
That's a great question. Getting access to the GPUs at this point in the market is definitely not the most challenging aspect. There have been times when supply chains make that difficult, but overall, that is not the biggest challenge. The biggest challenge is once you have them, making them work in a stable, reliable, scalable fashion, and in a way that that end customers don't need to worry about any of the complexity. And that's a huge topic. The very first thing that falls into that bucket is simply getting access to power. And this is the first number one most difficult thing in the industry right now. Not getting access to GPUs, it's getting access to power. The entire US is power constrained. The entire world is power constrained. And I believe we'll actually run out of power long before we'll run out of AI demand. But assuming you have the power, then yes, there's all sorts of other constraints that are very important, difficult to solve for when you're building these clusters. Networking is a big one, especially ensuring link reliability. These clusters have many tens or hundreds of thousands of connections. And depending on the workload, even just having a couple of those connections go offline for a couple of seconds can kill the workload and cause you to have to start over or restore from the last checkpoint. And that's a huge threat to productivity and potential waste of cycles for customers. And Meta has actually put out a lot of good papers on this. If anyone is interested in learning more about it, I would suggest reading them. But optimizing for link reliability, making sure that you design with that in mind, all sorts of tweaks and tricks in the physical design layout of the data center that you can make that increase network reliability. And then similar stories unfold for cooling architecture, like other aspects of the cluster design. And there's really this kind of gulf, massive canyon of IP between a naive deployment of a cluster and a really optimized deployment of a cluster. And while it might not be obvious to your average person looking at a picture of a cluster, every small detail matters when it comes to optimizing uptime and optimizing performance and making sure the cluster is as reliable as possible for the end customer.
So one of the things that I noted about your background is that you've mentioned Lockheed Martin, and you're part of a Skunk Works team and have a background and presumably a perspective on nuclear fusion and alternative sources of energy. Is that the replacement? Is that what's going to solve the problem to be able to keep up with demand, or is there something else on the horizon?
Over time, I believe yes. But I believe we're going to have a power crunch before that becomes a reality. The rate of growth that we're on, the rate of growth of power infrastructure, including these newer and innovative solutions, I think come 2027, 2028, we're going to run out of power. But a lot of these newer solutions like small modular nuclear reactors, other forms of green energy, I think we'll start to see a boom of that more around 2030. So there's going to be an in-between window where there's this massive demand that's unmet. The great news, though, is that AI really is providing that push for the country and the world to start adopting these newer, greener technologies. And that's amazing to see. We love to see that, seeing more demand for nuclear, solar, wind. It's excellent. And it's clearly needed in order to power what's coming. So that's a great silver lining. But I do think there will be a power crunch 2028, 2029. That's going to be a very tough time. At that time, it's just going to be whoever has power, like actual electricity, they're going to be the winners.
It's rare that I have an expert to talk to about data center architecture. So permit me this one other question. I got so many questions for you rattling around in my brain. I read that you intentionally chose to optimize your clusters for training versus inference. Maybe just talk us through that decision and what would you do differently if you made the opposite decision?
That's right. That's right. And the reason is multifold, but the simplest reason is a training cluster can do anything. You can do inference on a training cluster. The opposite is not true, right? So as a provider, we want to build the most flexible solution so that we can serve the needs of the maximum number of customers. Right? It would be far simpler, far cheaper to build inference-only architecture, but it wouldn't serve the needs of those customers. Right? And I think we'll see a lot of inference-only clouds probably get some traction. But as those clouds try to pivot into training, they'll discover that training, by comparison, is extremely non-trivial, extremely difficult, because inference you can do with some servers in a rack. It's much more aligned with a traditional cloud workload, right? The servers don't need to be massively interconnected. You don't need to necessarily have HPC principles implemented. You can get away with a much simpler architecture, but training is much more complex. So being able to support the maximum number of customers possible is the fundamental reason. But also, being the world's best at deploying AMD, it means that we have to solve the hard problems, right? And that's where the hard problems are: cluster operations, network optimization, being the world's first to implement Ultra Ethernet. Right? These types of things, these are the challenges we like to take on because we are the best in the world at deploying AMD clusters.
That's fascinating. Darrick, I didn't realize that a training cluster could be used for inference, but not the other way around. That's a good answer. I want to take the other side of kind of the discussion we've been having, and that is, I talked a little bit about quantum computing and some of my perspectives on the importance of it in the intro, and there are also potentially new AI architectures, new approaches to large language models and other kinds of AI designs, developments that could make the both the cost, but also the need for compute go down potentially. Obviously, it could be years away. What's your perspective on the potential? Not that we're just trying to catch up in terms of creating compute capacity, but might there also be a risk that we're overbuilding? And how do you think through that when you think about kind of a 10-year time horizon?
That's an excellent question. At the end of the day, this has been proven time and time again. Every time that there is a leap in efficiency or performance or architecture of AI, the overall demand for GPUs goes up. Right. And the reason for that is the cost per unit of AI, per token, per whatever, goes down because it uses less resources, uses less power. What that does is it enables new workloads. It enables existing workloads to scale. It enables new workloads that were priced out previously. The overall demand increases. And so then the overall demand for GPUs actually increases. The overall demand for infrastructure increases. And we've seen that play out over and over and over again. It's fundamentally Jevons paradox, right? Ben talked about a lot over the past year in the space. But if you look at the data, it's what we're seeing over and over again. So we do believe that will continue to happen. We are, in my opinion, nowhere near AGI. We have multiple foundational shifts and industry-shattering transformations that need to take place before we achieve that, right? And that's going to unfold over several years. And every time we have one of the big shifts, like, hey, we're not using transformers anymore. We're gonna do this other thing that's completely different but better in some way, right? Every time we have one of those shifts, we're gonna see this cycle unfold where there's this, massive decrease in the amount of GPUs and power needed for a specific workload, but then it's going to enable all these new workloads. And so we'll actually end up with a boom in more demand. And that's going to continue to unfold. And this is actually also why we like GPUs instead of alternative hardware designs. And that's because we believe that the strategy for doing AI, the architecture for doing AI will fundamentally change many times in the next decade. And so now is not the time to talk about building purpose-built devices. You can go build an ASIC that's great on transformers, but what happens when we stop doing transformers? Right? Then you have a paperweight. Whereas, the GPU will do the GPU is the perfect balance of flexibility and performance to meet these demands. I do think there's a far future 10 plus years from now where we have discovered the optimal architecture for AGI, like whatever that thing is. And at that time, alternative hardware, fixed function devices, those start to make sense again. But between now and then, we see GPUs being king, and we see demand increasing over and over again until we achieve that end state.
For those unfamiliar with Jevons paradox, and discussed it in the context of AI quite a bit, but essentially the demand for, in the case of applying it to AI, is elastic, and we'll keep coming up with new use cases as more capacity comes online. So really, we'll never be capacity constrained. Is that, would you say, a fair summary of the thesis there?
Yeah, we'll never not be capacity constrained, right? Like we'll always be constrained by the number of GPUs we have, not by the amount of demand that we have.
Yeah, good. Thanks for clarifying. Hey, Darrick, we're almost out of time, but I'm not letting you off the hot seat without answering one last important question for me. We've been talking mostly to Darrick, the technologist, and it's been a great conversation. Hopefully, everyone listening learned a lot. I want to shift focus and talk just for at least the last couple minutes before we wrap about Darrick, the entrepreneur. So I mentioned you're a serial entrepreneur. You're talking to a lot of entrepreneurs. What's some advice that you'd give maybe an earlier version of yourself, or what are some of the lessons that you think being a serial entrepreneur have taught you that you've been able to parlay into the success at TensorWave?
Yeah, that's a great question, Dan. I think that there's a few things. First of all, I've always loved business. I think I've been an entrepreneur since I was 8 years old. I always had side hustles and always trying to start businesses even as a kid. And it's always been a passion of mine. And so that the intersection between business and technology is really the sweet spot for me. I've always led technology-focused businesses and continue to plan to do that moving forward in my career. And I think it's very important in these types of businesses to have technical capability at all levels of leadership in order to really make sure that the team and the leaders can understand and strategize correctly on the projects at hand and the problems we're trying to solve. That being said, advice I would give to my younger self, I would say the biggest piece is think bigger. And I've been living that out for the past 10 years now. And it's continued to be true. Every time I start a new enterprise or a new venture, you start with this goal of X, then partway into it, you realize, hey, actually, I can make that goal 10X, make that goal 100X. And the GPU landscape is an excellent example of that, right? You go from, 100 GPUs to 1,000 to 10,000 to 100,000 to 1,000,000. We're really 10Xing every single year. And so this business especially is one where every time you think the next step is, you have to check yourself and say, actually, is that big enough? am I moving fast enough? Am I thinking big enough, or do I need to add a zero to this? Right. And that has held true throughout startups and throughout business during my career. Is usually if you dare to think bigger, there's a path to achieve that. So you end up being constrained by what is in your mind as the goal. So it's very important to make sure to think and dream as big as possible.
Darrick, it's good advice, but I don't think anyone could accuse you of not thinking big enough. Maybe it's good advice to your younger self. Darrick, this has been a pleasure. Whether you like it or not, you just became our resident data center architecture expert. Congrats.
It was great to be here. Thanks, Dan.
Yeah, well, please take me up on the invite. Come back and share updates as you and the team continue to achieve new levels of success. And we wish you all the best.
Thanks, Dan.
Excellent. Well, that's Darrick Horton, the great CEO of TensorWave. And gosh, that's all the time we have for this week on AI and the future of work. As always, I'm your host, Dan Turchin. And of course, we'll be back next week with another fascinating guest.